Okay, so here the initial count equals FF minus the number of counts plus 1. Okay. So FF is 256 minus the number of count, which is 8. So 255 minus 8. What is the value?
F7.
We have FF minus 8.
$247.
So F is 15. 15 minus 8, the value is
247
7.
in hexadecimal.
F minus 0,
F.
so we have F7 plus 1. The result will be F8. Okay. So here to have 8 pulses, the initial count should be F8. So the formula, how to find the initial count, it will be the largest value minus the number of count plus 1. So this formula, is it not the same as the 2's complement? If you are in, for example, base 2, we have to make the maximum minus the value that we need. You have the result plus 1. So it is the 2's complement. So we can just take minus the count, minus the number of count. And instead of calculating this, we can have move LW. Instead of having FF minus the number of count plus 1, we can make minus the decimal value of our count, which is 8. And then move WF times 0. Okay, so this is if you are in 8-bit mode. So we can calculate FF minus the number of count plus 1, or you can make it just minus the number of count. This is in 8-bit mode. Okay, so if we try to use all the cycles of all these instructions, you can see that these instructions will take 16 cycles. Okay, and when you start your timer, this will generate 48 cycles. So the total number of cycles will be 16 plus 48. So the total delay will be 48 plus 16 multiplied by 0.4. This will be the delay. So here, this will generate a square signal with a frequency of 19 kilohertz. Okay. But generally, the initial count, because we have from 0, 0, 0, 0 till F, 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 F. So here, if you are using 16-bit mode, here we have more than 65,000. The number of count can be greater than 65,000. So we can ignore the 16 bits that you have due to this instruction. So we can ignore these 16 compared to tens of thousands. So generally we ignore these 16 bits. Okay. So how to find the number of count? We have seen this. So assume that the timer 0 low and timer 0 low, the timer 0 high. Here we have 4 nibbles, so we need 2 bytes. Let's suppose that we call them YYXX. XX is the value of timer 0 low, and YY is the timer of 0 high. Okay, so how to find this number? So we can work in hexadecimal or in decimal. Okay, so in hexadecimal, the number of count will be the largest value, which is FFFF, minus the number of counts plus 1. If you want to work in decimal, so you can convert this FFFF to decimal. It is 65,536 minus your number in decimal, which is the value of YY, XX. Okay, so here it is 35 and then plus 1. So we can make it directly 65,536 directly. Okay, so this is how to find the value of timer 0 low and timer 0 high. Any question about this? So here you have the number of counts. And same thing, if you want the initial value, the initial count, you have the same formula. So it is the FF minus the number of counts plus 1. Same thing. So the time delay depends on two factors that are not controlled by the program. So the crystal frequency and the internal architecture of the registers. So how can we design a certain time delay? So we as a programmer, we can use or we can modify the initial count, or we can use the prescaler. So the initial count is the value that we load to the timer 0 low and timer 0 high. Now, if the delay that we want to generate is less than the delay max that we can use. So what is the delay max if you are using 16-bit mode? So the delay max equals our period T multiplied by the maximum number of counts, which is 65,536. If our delay is less than the delay max, so no need for rescale. But if our delay is greater than the delay max that we can generate, then we need rescale. Is this clear?
Yes.
Clear.
Okay. So if the delay is less than the delay max, so no need for the prescaler. So how to define the initial count? Okay. So first of all, we have to find the number of counts. So the number of counts will be the delay divided by the period T. So the number of counts. Number of counts equals our delay divided by our period T. So this is without prescaler. Once we have the number of count, we have to find the initial count. The initial count we have seen that is, so if you are in 8-bit mode, you can take just minus this value, okay? Or we can just make FF minus the number of count plus 1. So this is the initial count. So let's suppose that our initial count is, for example, 3026. This is the initial count. What is the value of timer 0 low and timer 0 high?
High in hex.
No, here you have decimal value.
30 for high, 26 for low.
So this is a decimal value. So we have to convert this decimal value to exact decimal.
0BD2.
What is the value? Okay, let's convert. Let's use the calculator. Okay, so I have 3026, and you have to convert it. 3026, you have to convert it to hexadecimal. So I have BD2. So it is 0xBD2. So the D2 will be the value of timer 0 low. We have 0xB2. D2. So the D2 will be the value of timer 0 low, and the 0B will be the value of timer 0 high. Is this clear?
Yes.
Now, if your delay is greater than the delay max, if our delay greater than delay max, what is the delay max? The delay max is the period multiplied by the number of count, which is the max. In that case, we have to use the prescaler. So what are the values of the prescaler? So the prescaler can be 2, 4, 8, 16 till 256. So which one we have to select? So here we have to find the smallest alpha, the smallest value of alpha, okay? So here, what do you want to find? You have to multiply this delay by a factor alpha, okay? So that our delay will be greater than the delay max. So how to find this alpha, Shabab?
We substitute for T and D, and then we have one unknown.
Substitute what?
Yes, we have T and D, and we divide like T multiplied by 6,536 by D, and we get T.
We want to find alpha.
Yes, we get alpha, sorry.
So alpha will be the delay divided by the delay max. So what is alpha? Alpha is the delay. We have to find the smallest value. Okay, so it is the delay that we need divided by the delay max. Okay.
Yes.
So if we suppose that our delay max is 1 millisecond, and the delay that we need is 3.5 milliseconds. So what is here our alpha? So if you divide 3.5 by 1, so alpha should be 3.5. We have to find the smallest value that is greater than 3.5. So alpha should be greater than D divided by the delay max. So what is the smallest value that is greater than 3.5 from these values?
4.
4. There you go. So our alpha should be greater than our delay divided by delay max, but we have to select the smallest value. Okay, so here we have the delay max. This is the delay max, okay? Multiplied by alpha is greater than or equal to our delay. So alpha should be greater than or equal to our delay divided by delay max. So here in the previous example, our alpha is 3.5. The largest value or the smallest value that is greater than 3.5 is 4. So I have to select alpha equals to 4. Now, if you selected alpha equals to 4, how to find the number of counts? So without prescaler, with no prescaler, we have seen that the number of counts equals to the delay divided by the period T. Okay, with prescaler, our T, it will be alpha T. Okay, so the number of counts will be equals to the delay divided by not T but alpha T. And alpha should be one of these values. So we have to select the smallest value that is greater than the value that you found. Is it clear?
Why would we divide by T to get, like in the no NPS? We divide by T to get the
So here we have to divide by alpha t. So because we are giving the prescaler, we are using prescaler. The prescaler will divide the frequency by 4. In this example, that means the delay will be multiplied by 4. Okay.
Okay, and T, what's the value of T? Like, depends on the X.
T is our period. T, which is the
Okay.
capital letter T that we have seen previously, which is 1 divided by the crystal frequency divided by 4. Okay.
Yes, clear.
Okay. So timer 0 programming in 8-bit mode. So we have to load the value of timer 0 control. We have to load the value of timer 0 low by the initial value that you need, and then we have to start the timer. This is the configuration. And then we have to keep monitoring the timer. Once it becomes high, we have to stop the timer. So bit clear 5, timer 0 control, timer 0 on. We have to clear the flag, and you have to repeat the steps from 2 to 1 minute. Is this clear?
Yes.
Okay. Now let's see how to use the timer as counter. Do you need example, Shabab, before moving to the counter, or is it okay?
Clear, inshallah. مدري.
So you are able to find the initial number of count, the number of counts starting from the delay.
But doctor, here when we use a scalar, we will get a little bit like more than higher than the delay required. Is that fine?
No, we change the initial count. Shabab, same thing.
So-
After 10 minutes, you have to reconnect by using the same link. Okay.
Yes.
So once you select the prescaler, you have to calculate the number of counts again. So the number
So
of
we
count will be
can
the delay divided by alpha t. Okay.
okay. Yes. If there is a solved example, it will be helpful.
Okay, let's generate a time delay. Okay, let's use the counter to generate a delay of 3 milliseconds. Yalla, do we need prescaler? Let's use, for example, 4 megahertz crystal frequency. And we need a delay of 3 milliseconds. So what is the value of the initial count? We need everything. Yep. Let's use white. Okay, so here we need a delay. Three milliseconds, and we have crystal frequency equals 10 megahertz or 4 megahertz. Yalla. First of all, we have to calculate the period T. So what is the period T?
1 divided by x. 1 divided by x. Yes.
So here 1 divided by 1 megahertz, which is 1 microsecond. Okay. Now, let's calculate the number of count. So what is the number of count?
Delay divided by t.
Okay, we have the delay divided by our period T. So the delay is, let's use the same unit. So 3000 divided by, so microsecond divided by 1 microsecond. It is
3000 minus
3000 thousand. So this is the number of counts. Okay, so here do we need prescaler?
If we use 8-bit or 16-bit?
Okay, so here can we use 8-bit?
No.
No. So 8-bit, if the number of count is less than 255 or 256, then we can use 8-bit. But here we have 3000, so we have to use 16-bit. With 16-bit, what is the maximum number of counts? I've seen that it is 65,536. So you can see that this number is less than
Yes.
the number of counts. So our delay is less than the delay max. Yes or no?
Yes.
Okay, so here we have to calculate what? So this is the number of count. Then we have to calculate what? The initial count, which is the value of timer 0 low, timer 0 high. Okay, so what is the value of the initial count?
F minus
So here you can use in hexadecimal or in decimal. If you convert this to hexadecimal, so you can convert this to hexadecimal and work with hexadecimal, or you can use the decimal. Okay, so if you work with decimal, so we have 35,000 or 65,536 minus 3,000. So what is the result? يلا شباب
62.
6
536.
536. So we have to convert this to hexadecimal. يلا convert to hexadecimal.
F448.
F.
448.
Okay, so this is the value of timer 0 low. And this is the value of timer
High.
0 high. Okay, so what is the delay max? So the delay max is 65,536 multiplied by 1 microsecond, which is almost 65.53 milliseconds. So you can see that our delay, which is 3 milliseconds, is less than the delay max. Now, if you want that our delay equals 100 milliseconds. So here you can see that 100 milliseconds is greater than the delay max. So here we need 3 scalar. So we have to find alpha. So alpha should be greater than the delay, which is 100, divided by the delay max, which is 65.53. So 100 divided by 65, so it is
526.
1.52. Okay, so what is the prescaler here?
2.
So alpha should be equal to 2. Now, what is the number of count? So the number of count will be the delay divided by alpha multiplied by the period. Okay, so our delay is 100 milliseconds multiplied by 10 to the power of minus 3 divided by alpha, which is 2, multiplied by 1 microsecond. So what is the number of count here?
0105 and a decimal.
Multiplied by 10 to the power of?
Oh, no.
So here you have minus 3 and here you have minus 6.
Yes, 50,000.
50?
50,000.
50,000. So here, this is how to calculate the number of counts. Once we have the number of count, we have to find the initial count. Once we found the initial count, we can start our program.
Yes.
Okay?
Yes, clear.
Okay, let's have a homework for next class. Let's have a homework for the two sections, okay? You want to use you want to generate a signal of 35 let's make 350 hertz on the pin C0. Write a program to generate this signal. So we have 350 hertz, which is the frequency. From the frequency, we have to find the period. Then we have to find the period, which is 1 over f. From the period, we have to find the delay, which is the period divided by 2. Once we have the delay, you can continue. Okay? Yalla, this is your homework for the next class, inshallah.
Doctor, don't we need any more information about the bit configuration and the
You need just to know the crystal frequency. We use the crystal frequency, the same 4 megahertz. Okay? This is what you need as information. Yalla, let's continue. We have seen how to